The last part of the ramp is about the spiral shapes. For example, you have a ramp especially for a yard, for a site, and you just want to design something, and now it has two forms. Either the length is important to you or the slope. So when you calculate this, you see that you need to have, for example, this amount of length to have any slope, for example. So now let's just design it. For example, I would just want to design a free form with that 1.20 height only with a free form. Well, I start designing and I suggest you start with the line. Select the detail line and then just start designing, start drawing. Just like this, I design. And finally, it reaches here. Well, now you have considered a length for your ramp. What you need to do now is to, based on the length of these lines that are written here, you need to calculate the slope. For example, we have 12 meters here. You can calculate it exactly. And 9 meters here equals 21 meters. Then we have 6.7t here, 27.7t. And let's consider this one 3 meters. So we have 30.7t meters. And let's just say 30.5 meters, the length of this line. So now we need to use the calculator. Just like you can see. Now we have 3.9. We can say about 4. Now the slope is calculated and it's 4. But you might say, no, that's not enough. And I say, all right, let's change it. Let's delete this one. For example, all right, it's an example. So now that 30 centimeters 0.5 must be minus 12. So I calculate this again. And that's it. The slope is about 6. Therefore, this is a completely manual process. It's up to you that how much you want the slope of the ramp to be. This is one way. Another way is that you don't care how much the slope is, you just want it to reach there. We have this line and now we want to design a ramp based on it. So select your ramp and then boundary. How much you want the width to be? For example, 2 meters. So pick line. The offset would be 1 meter. And now you need to place these. You can also tab if you want. Just based on what I told you, riser must be vertical to the boundaries in the end and the beginning. So if you want to form it like this, either make it this way and adjust the floor with it. You can't say that I want the end of my ramp to be this way. You can't, it will be slanted. Either make it this way or cut it from a little back. Alright, just like this. And then you can adjust your flow. I will do it later. So this is our ramp. Now we also calculated the slope. Now finish. Well, an error. When you have several ramps that are connected to each other and they're curved, we see this error and sometimes we just don't. It designs it, but in the wrong way. For example, your ramp, instead of going only up, it goes up and then comes down and again goes up. In any case, it makes this mistake. When you have several curves connected to each other, this might happen. But what is the solution? Well, the solution is to pick the riser first and create some fake landings for it. We have this problem only because we don't have the landing. So, how do we design a fake landing? Well, this is what you need to do. First of all, you need to design, I call them double risers. There are some really close risers to each other. Now, Revit considers this small distance a landing, but it's not a landing to us, and it can control your ramp. So design a double riser at the end of each of these arcs, and you see it completely looks like a line. And you do this when you don't have a landing. If you have a landing, well, you don't need to do it. Nothing will go wrong. And that's it. And this warning you see is because of the slope of the railing. Don't pay attention to it. We will talk about the railings. So let's see the 3D and go for its settings. So select it and say from level 1 to... You could have done it before that too, right? I just forgot, which is okay. From level 1 to level 1, 1.20, and it comes down. But only if the slope in edit type is not, for example, 2%. For example, now based on our calculations, the slope must be about like 4 or 5%. When we deleted the first one, it became 6%. If all of it remains, I think it's about 4 or 5%. What you just allowed, I mean the ramp maximum slope, must be about 10% so that it can be allowed to reach there. So, the first point is that the slope must be calculated manually. And the other point was that there must be a double riser at the end of each of these arcs. And we must not adjust the end of this with the floor. The floor must adjust itself with this, right? So I delete the line. Now you need to adjust the floor. And if you don't want it to become like this, adjust it in this way. You can even use arc in this way. That actually depends on your design. Or you can even delete this here and do this, right? Anyway, just adjust the floor, right? You see? This is the perfect design. In this way, you can also design any ramps in the yard or the site. The only problem is that you cannot control the slope that well, right? Well, in the next part, we will talk about the ramps that rotate. And you can also use that. Just design this one more time so that you can learn this in the best possible way.